Hello and welcome to the Maths Diagnostic Question of the Week number 17 with me, Craig Barton, where each week I pick out a question from my Diagnostic Questions website and I have a look at the answers that students have given and crucially the explanations that students have given for those answers in a bid to see if we can uncover and resolve some important student misconceptions. Now the question that I've picked for this week's analysis is one that I set to my year 11s, and it's I was teaching them the topic of vectors and they'd never done vectors before, but the question itself that I set them isn't anything to do with vectors. It's actually to do with negative numbers and fractions. But the problem was students were getting to the end of these vectors questions and they were doing some big juicy 5 or 6 mark vector geometry questions, and then they were getting to the end and they were faced with things like, I don't know, minus a third a plus 3a, and they had to simplify their answer. And they came really unstuck, and they were coming up with all kinds of answers for it, very few of which were actually right. And in the student's head, they were then thinking, oh God, I can't do vectors. When in fact, the truth of the matter was that they couldn't do a very precise, specific skill, namely adding negative fractions onto whole numbers. So I decided I needed to isolate that skill, get it tested, get the misconceptions resolved, and then get back to vectors. So I'm going to show you the question that I wrote for the students. To find any of the questions on here, if you go to data questions, this is quite a nice way of doing it. This is going to allow you to hone in on the most answered or most misanswered questions, whatever you want. I'm actually going to change my filter to most answered because I like it when I get as much data as possible. And let's see if I can find the question that I had in mind. So I'm going to go for a bit of mathematics. I'm going to go for a bit of number. And then I think it's under fractions with any luck. Let's go to fractions. And let's have a little look down, and there's a few here, and here's the one I want. Perfect. So let's have a click at this. Minus 2/3 add on 2 equals, and there are your 4 possible answers. Now at this stage of the video you might want to give it a pause, and I'd like you to have a think. Firstly, what do you reckon the right answer is? Secondly, how would you explain that right answer to students? Thirdly, what do you reckon the most popular incorrect answer given is? And what do you think some of the reasons students give for some of those incorrect answers are? So give the video a pause, and when you've had time to think, just resume it. Hello, welcome back. So let's have a look at this. Now, if my maths is right, A is the correct answer. And as I say, not many students, when faced with this kind of question in the context of vectors, were getting this right. So they were getting through all the vectors work, and then they were being faced with minus 2/3 of A plus 2A equals, and they just couldn't do it. So let's have a look at some statistics. If I go to advanced here, and this is for all users in the world, we can see that this question at the time of recording has been answered 171 times, and it's been got correct 125 times. Let's just change that to percentages. 73% of people are getting it right. That's pretty good, but C and D are causing no end of trouble here, and that's quite significant, that, because again, it's not just a case of students dropping a couple of marks at the end of a vectors question. In their head, they are struggling with the whole topic of vectors. And also, this thing sneaks its way into indices questions with some nasty negative indices that you need to simplify. So first, let's have a look at some of the reasons students have given for the correct answer. And there's some absolutely beautiful ones here. I'm just going to pick out a couple of my favourites. I like this one, just nice and concise and simple, just changing them, changing the fractions over thirds, and then knowing that minus 2 over 3 plus 6 over 3 is equal to 4 over 3, which is 1 1/3. And indeed, that's the most popular answer, nice and concise. But there's some absolutely beautiful ones given here. This explanation here is kind of a longer form of that first one, and it just talks through the logic of why you need to change them, which is an absolutely lovely thing that I really like. This is a nice one as well. What about this? Changing the fractions into decimals and thinking about it that way. A really interesting way that I never would have thought to do it, which is absolutely lovely. Simple things here. When you add a positive number to a negative number, it's going to get bigger, so that's going to rule out a lot of them, so which is really, really nice. I really like this one. This is lovely. This, I thought of all the numbers as thirds. 2 is 6/3, and you have to add on 2/3 to get to 0, and you have 4/3 left. Lovely that. I have to add on the 2/3 to get you to 0, and then you've got 4/3 left over from that 6/3, which must take you to the answer of A1 and a 1/3. Really, really, really like that. There's one other one that I absolutely loved, and I'm just going to try and find it here. Let me have a look. Where is it? Yeah, here you go. What about this one? because if I took 2/3 away from 2, there is still one whole number. I would have never thought to explain it like that. Just think of it the other way around. 2 take off 2/3. 2 wholes take off 2/3. Absolutely brilliant that I would have never thought of. Now, the important thing to stress here is students who've come up with some of the wrong answers here can benefit by reading through all these explanations until they find one that makes sense to them. And these are explanations given by actual students from all around the world. But as teachers, I want to know why students are coming up with B, C and D. So let's have a little look at this. Let's go for B. Now, not many people have gone for B, only 4%, and indeed just one explanation, but it's an interesting one. 2 as a fraction is 2 over 1, absolutely correct. Minus 2, add 2 equals 0. So specifically, they have a misconception when it comes to adding fractions, thinking that you can just add the tops and bottoms. So that is a specific misconception that student that needs resolving, and hopefully it will be resolved by them reading through the correct explanations for A. What about C? So C was minus 4/3. Can you think why students might have given minus 4/3? And quite a few of them did. Let's have a look and have a read through some of these ones. Yeah, very, very, very interesting. A lot of these students have correctly changed the two wholes into minus 6/3, but then they've messed up when it comes to the adding of the negative numbers here. So we've got that one is changed into minus 6/3, but here when they've added minus 2 onto it, they've ended up with a minus 4. Sorry, they've got to minus 8, and minus 8 over 6 is minus 4. So a very big misconception there. I like this one here because if the denominators are made the same, you get minus 2 over minus 3 and minus 6 over 3, and if you add them together, you get minus 4 over 3. So C for me is revealing a different kind of misconception. Here the problem isn't with fractions, they're very comfortable dealing with the fractions, but here the problem comes with adding negative numbers, a specific misconception that can be isolated, identified and resolved. And finally, D is an interesting one. Now when I wrote this question, I came up with D thinking that students might do something like this. They're on minus 2/3, they add on 1 whole, they get to positive 2/3, they add on another whole, they get to 1 whole and 2/3. But when I actually read through D, absolutely fascinating. It revealed different reasons that students have given for that, and quite a few have gone for D. And again, I'll leave you to read these more thoroughly in your own time. But the gist of it here is it's more of an arithmetic error. Students are pretty comfortable changing that 2 wholes into 6/3, which is really, really nice. But then they're struggling when it comes to actually adding minus 2 to 6. And I think perhaps some of them are missing out the 0 when they're counting up or something along those lines. But it's absolutely fascinating to read through some of their explanations for why they've got that. I actually set this question as part of a weekly quiz to both my Year 11 class and my Year 8 class, and that allows me to do this when I'm logged in. I can go for filters, I'm on my advanced filter, and I'm actually going to just isolate all the students in my Year 11 class, so let's isolate those, and I can compare that to the global average, and I can see that my students are actually doing pretty well, as I'd hope they would do. They're a top set Year 11 class, but still I've got some lingering misconceptions in there. And if I go for all here, I'll be able to actually read what specific students have come up with different explanations there. But I also decided as a little experiment to set it to my Year 8 class as well. If we apply the filter there, we get my, and what I'm going to do is I'm actually going to take that cohort and just delete it. So now I've got my Year 11 class versus my Year 8 class. And I can see that, again, as I'd expect, my Year 11 class are outperforming my Year 8, but specifically I can see that the answer of D is much more prevalent in my Year 8 class. And once I identify that, that's when I need to delve in and start to try and figure out why is it my Year 8s are going for D, and I can start to read through some of their explanations to try and figure out why. So there is a very important question, I feel, not just for the question itself, but for how failure to be able to do that skill can hinder students' progress in other topics, namely vectors and indices. And there's a little kind of guide through how you can read students' explanations from all around the world, but specifically if you set this as part of a quiz, you can then go into far more detail with your individual students' explanations. And to finish, if I just give that question just a little click on itself, if you scroll down to the bottom here, there's a little button here called Related Quizzes, and if you give that a click, it will show you any quiz that contains that question. There's the one I was talking about that I set my Year 11s, there's the one I'm talking about I set my Year 8s, and here is a quiz I wrote that's based on that exact same skill, but this time also involving decimals and fractions. Hope that was useful. Let me know how your students get on with that, and I'll be back with a fresh question of the week next week. Take care. Bye for now.